To give a first example of why multi-threaded processes and writing applications that can run in parallel is challenging, let's look at this question. Let's assume we have a program. Initially, it was designed to run on a single core, but now we buy 100 cores and we want to make it more efficient. So what we do is that we start rewriting the code and we do a nice job. Eventually, we end up with only 25% of the initial program, so 1 every 4 lines, that cannot be executed in parallel. If we now run this with 100 cores, how many times faster will this program be? The answer to that is in between 1 and 10. So actually it turns out that you can get a limit or an upper bound on how much your parallel process can be faster compared to the sequential one or serial one using Amdahl law. So let me move this. If you see the speed up, it's always less than or equal to this formula. So here you have 1 divided S, which is the portion that is not parallel, plus the portion that is parallel that gets smaller and smaller with the higher number of cores you use, which in this case it's N. If you use an infinite number of cores, then this component here disappears, and what you are left with is 1 divided S. That is the limit for the speed up. S in our example is 25%, which means that this program will never be faster than 4 times its serial counterpart, no matter how many cores you use. So the serial portion of an application has disproportionate effect on the performance gain by adding additional cores. And with this, you can actually compute which is the maximum speed up.